Okay, in this part, we're going to take a look at taking the second derivative and then doing some problems from tables and graphs like we did in earlier sections. Okay, so we're going to take the first derivative of this using the chain rule. Now, this is one of the easier problems. This is like one of the very first chain rule problems we might have done. Okay, so the inside function is 5x minus 17. So we're going to do the derivative of the outside. So I'm going to do 3 times 2 is 6. Decrease the exponent by 1. There's the derivative of the outside with the inside left alone times the derivative of the inside, which is 5. Now, if you have to find the second derivative, you want to simplify a little bit. At the very least, take this 5 and multiply it by the 6 that's up front and make this 30, 5x minus 17 squared. Now, when I go to take the second derivative, it's not much different than taking the first derivative. Okay, the inside function is still 5x minus 17. Oops, the inside function here is still 5x minus 17. I'm going to do 2 times 30 is 60, derivative of the outside. This becomes first power, inside left alone, times the derivative of the inside. And you can leave it like that if you want to. You could do 5 times 60 and get 300 and make this 5x minus 17, and you could even distribute the 300 if you wanted to. But this first answer up here is fine. Okay, in this problem, we're going to do derivatives using the chain rule and a table. Now notice up here that it says that h of x equals f of g of x. That's a composite function. It's a function inside of another function. So to find the derivative of h, we have to use the chain rule. So the outside function is f. It's the derivative of the outside with the inside left alone times the derivative of the inside. Now if you look on your pink derivative sheet, this is exactly what the chain rule says. It says if you want to take the derivative of f of g of x, it's f prime of g of x times g prime of x. Okay, now if I want to find h prime of 1, I'm going to get the numbers that I need from the table. Now for some reason this confuses people. I'm going to go ahead and plug this in and then I'll show you where the numbers come from. They try and multiply everything to like 3 things together usually, and that's not going to work here. So we're going to start with this. First I'm going to find g of 1. Okay, so here's function g, here's 1, g of 1 is actually 2. Okay, so instead of g of 1, I'm going to write 2. This is f prime of 2, and then it's times g prime of 1. Okay, so I always do this step first, and then I look the other 2 up, and then I multiply them together. So now I'm going to find f prime of 2. Well, f prime of 2 is 7. G prime of 1 is 3, and so the answer here is 21. Pause the video for a second and see if you can find h prime of 2. Okay, h prime of 2, I'm going to use the same derivative rule here, should be f prime of g of 2 times g prime of 2. So I'm going to find this piece first, g of 2. I look up here in the table, and g of 2 is 1. So now I get f prime of 1 times g prime of 2. Okay, f prime of 1 is 5. G prime of 2 is 4. 5 times 4 is 20. We're going to do the same thing for this one, except for it's going to be from a table. Okay, so h of x is f of g of x. So h prime of x is the derivative of the outside with the inside left alone times the derivative of the inside. So if I want to find h prime of 3, it's f prime of g of 3 times g prime of 3. And just like on the last ones, I'm going to find g of 3 first. So g of 3 is the y-coordinate of g at 3. Okay, and it looks like that's going to be, let's see, here's 3, here's g, it's going to be right there. Okay, so g of 3 is the y-coordinate right here, which looks like it's 5. So this is f prime of 5 times g prime of 5. Now remember, or I'm sorry, g prime of 3. F prime of 5 is the slope of f at 5, the derivative of f at 5. So here's f, here's 5. the slope of f at 5 is the slope of this line right here, which is 1/2. The derivative of g at 5 is the slope of g right here at 5. And that's going to be negative 1/2. 1/2 times negative 1/2 is negative 1/4, and that's the value of h prime of 3. Okay, for the next one, s prime of 9. Notice that s of x is g of f of x. So the derivative of s will be the derivative of the outside with the inside left alone times the derivative of the inside. So g and f have switched. Now I'm going to try and find s prime of 9. So g prime of f of 9 times f prime of 9. And just like before, I'm going to find f of 9 first. Okay, so here's 9. F of 9 is the y-coordinate right up here. And it looks like f of 9 is 8. The y-coordinate right there. Okay, so I need g prime of 8 times f prime of 9. So g prime of 8 will be the slope of g at 8, which is right here, negative 1. F prime of 9 is the slope of f at 9, which is the slope of this line segment right here, which looks like it is, I think it's 2. And so that's negative 1 times 2, or negative 2. And that would be the value of s prime of 9. Okay, these two problems right here, people get confused on which is which. Okay, so when you see cosine cubed, we've talked about this before. Cosine cubed of x is the same as cosine of x cubed. But when you see cosine of x and then the cubed, that's this right here. Okay, so in the first function, cosine of x is actually the inside function. So if you're trying to take the derivative of this one, the inside function is cosine, the outside is the cubed. So the 3 comes down in front, derivative of the outside with the inside left alone. And here's the inside left alone. And then you would multiply by the derivative of the inside, and the derivative of cosine is negative sine. For this one over here, however, the inside function is x cubed. So if you're trying to find the derivative here, the derivative of the outside is negative sine with the inside left alone, x cubed, and then you'd have times the derivative of the inside, which would be 3x squared. Okay, now if you wanted to simplify these and know what the multiple choice answer might look like, this would be 3. They would probably write cosine x squared as cosine squared x. They'd move the negative out here in front of the 3, and then they'd put the sign here. This is an equivalent answer. For this one over here, they'd move the 3x squared up in front with the negative, and then write sine of, and then they'd have the x cubed like that. Okay, there are practice problems on my webpage calendar. There are also solutions to these. You need to practice these. I would suggest especially from 91 to the end. Okay, these problems here with the, especially like 109 to the end. The ones that have, where you have to get the values from the table or the graph. Those are from the graph, and on the next page I have some here from the table. Those are the ones that are most likely what you will see on the AP exam. If you felt like you were struggling with some of these up here, where you were actually just using the chain rule to find the derivative, like 51, 25, those are ones that are very much like things that you might see as well, even 23. The ones with the fractions are a little less common, but 51, 23, and 25 are extremely common.